preparation of amine. Okay, see here. Amines are the functional groups containing nitrogen. So I had been telling you repeatedly, whenever you go for preparation, do not follow blindly or try to by heart. So we have to start those compounds which already contain nitrogen, or we have to incorporate nitrogen from outside. Okay. Second thing is that second thing, we have already seen that amines can be classified into three categories: primary amine, secondary amine, and tertiary amines. So there are some preparations in which you'll find all three amines are formed, and there are other preparations in which only selectively a specific amine will form. Either it will form primary amine, secondary, or tertiary amine. Okay. So now we will classify this into two categories: preparation. One, preparation of mixture of amine. In this preparation, primary, secondary, and tertiary amines are formed. Can you hear me? Hello?
Yes, sir.
Okay. Because I'm not using Bluetooth. My Bluetooth is getting some problem. So, in this case, we'll call it a monolysis of haloalkanes. This is also known as Hoffman monolysis. Hoffman monolysis. Okay. In this process, a mixture of haloalkanes and ammonia is being heated in presence of a base in a seal tube. Why you do in seal tube? Otherwise ammonia vapor will go out. In a seal tube. In a seal tube. It forms primary, secondary, tertiary amines along with quaternary salt of ammonia. Is right. Then we'll do the preparation. Finished?
Yes, sir.
Okay. Okay. Now say I have taken ethyl bromide. I'll write like CH3, CH2. Yeah, you can take any haloalkane. So I treat it with ammonia. So first, what will happen now? They undergo nucleophilic substitution reaction. Okay, plus. So what will get now?
That part cannot be seen, sir. The
Up to
arrow.
this, up to this
There
one.
we can see, but right after the arrow we can see.
This one you can see.
But right after the arrow we cannot see.
And the one which you're pointing at.
Oh, from here you can't see. Oh yes, some reflection is there. Correct. Okay. I'll write it in this. So yeah, some reflection is there because I'm using bright light now. So I'll write like you get now here CH3, CH2, NH plus H. Now you can see it.
Yes, sir.
Okay. If I write anything now, can you see it? Yeah?
Yes, sir.
This reflection is there.
Only that part.
Yes, it's the same line with the reaction.
So this up to this much you cannot see, na? Okay. So this is called ethylamine. Ethylamine plus H. So what is this? This is primary. Okay. See here, very interesting thing. Ammonia is a nucleophile. So it has undergone nucleophilic substitution reaction. Moment you form ethylamine, this is a stronger nucleophile than this. Why? Because your ethyl group is electron donating. So it supplies more electron to the nitrogen. So this nitrogen become more nucleophilic. Now there is a competition between this and this. Obviously, better nucleophile is going to react. So the next molecule of this will react with this, will not react with this. All right. So I'll write like this. Br CH2 C. See, whatever we are saying theoretically now, experimentally you can prove it. So now what we are going to get? I'll write like this, huh? See, you get this plus HPA. So what is the name of this one? This is diethylamine. Diethylamine. Okay, this is a secondary amine. Plus you get here HB. HB I have already taken. Okay. Now this is having two ethyl group. So it is stronger than this. So the third molecule of haloalkane will react with this. Okay. So right now here CH3, CH2, Br. Okay. Now here I have to write heat. Here also I have to write here heat. Okay, I'll write here heat. Now see. You go out. So now you get here CH3, CH3, CH2 and CH2, CH3, CH2, CH3 plus Hb. Okay. Now this is triethyl amine. This is a tertiary. Triethyl amine is the strongest nucleophile because of the presence of 3 alkyl group. So reaction will not stop here. So it will again going to react with this. Okay. So ultimately you get here CH3, CH3, NH2, C. Now this nitrogen does not have a lone pair. His valency has become 4. So because of that we call it ammonium salt. But in that case, see, NH4 has a positive sign. This also have a positive sign, and it has to be neutralized by a negative sign. So this is the Br minus. Okay, so what will be the name of this one? 1, 2, 3, 4. We will call it tetraethyl ammonium bromide. So the name is tetraethyl ammonium bromide. Okay, so this is a quaternary salt. Quaternary salt. ট্রেন শব্দ শুনতেছি বুঝা মুখে হয় না, কিন্তু পাশাপাশি সব বাড়িতে ট্যাঙ্ক আছে না, বুঝাই যায় না কোন আমরা ট্যাঙ্কে জল পড়তেছে না ওইদিকে ট্যাঙ্কে জল পড়তেছে, বোঝা যায় না। Finished? Done? Ne?
Yes, sir.
Okay. Then please write down. The amines so obtained are separated by fractional distillation. Okay. Okay. Then I'll tell you. This is not be given in your book. Write down below. Note. Then write controlled amination. Controlled amination. Then write
The control what?
amination. AMMINATION, controlled amination. Then right here. 1. Heating. Heating haloalkanes with excess of ammonia give only primary amines. It is if you take large volume of ammonia, then in that case you will get only primary. Okay? So I'll write now here R CH2X. Okay, I'll write CH3 CH2 Br plus ammonia. Okay? Write here base and I'll write here heat. Only you will get here primary. You get here only ethyl that is you get here only primary. Second, heating large excess of haloalkane with ammonia give the corresponding quaternary
So what's that after heating? Is it large?
heating large excess of haloalkanes. Heating large excess of haloalkanes with ammonia give the corresponding quaternary ammonium salts. Okay. So right now here 4 CH3 CH2 Br plus ammonia, then base, then heat. Okay, it will give you you'll get here tetraethyl ammonia bromide. Tetraethyl ammonium bromide. Finished?
Yes,
Yes,
sir.
sir.
See, when you want to prepare them industrially, now in small amount you can afford. When you want to prepare industrially, in that case we avoid this one. Why? Because haloalkanes are very costly. So we do not prepare by this method. Anyway, this is not being written in your book, but we should learn it. What we do, instead of taking haloalkanes, we take alcohols. Right, second method, a monolysis of alcohols. A monolysis of alcohols. The second method is for mixture of milk. Lysis of alcohols. Right. When vapors of alcohols and ammonia are passed over heated alumina. Alumina is Al2O3 or thoria. Thoria you do not know. Thoria is the common name of thorium dioxide. At 620 Kelvin, give a mixture of primary, secondary, and tertiary. Here it does not form salt. Salt is not formed. You get a mixture of primary, secondary, and tertiary. All right. So now you can write similarly as you have written. Instead of Br, you put OH. So I'll write here CH3, CH2, OH, and H. Okay. Condition is what? It is Al2O3 or THO2 620. Okay. So is here where there you found where HBr has gone out. Here you find elimination of water molecules. So what you get now here? You'll get here CH3, CH2, NH2. So you'll get here. I'll not write the name now. You know the name. Because primary amine plus water. Okay, water I'll write. H2O. Then again it is going to react with another molecule. CH3, CH2, OH. Here I'll write Al2O3, TaO2. 620 Kelvin. Will go out. So here you will get CH3, CH2, NH, CH2, CH3. Okay? So this is a secondary. Secondary. Then again this is going to react with another molecule. Al2, O3, THO2, 620. So ultimately you get here tertiary amine. So this process, this is industrial process. So whenever you finish, please from your side tell me yes, you finished. Yeah, the others, how do I know?
Done, sir.
Okay. So now these are the two preparation we have done for where you get a mixture of amines. Okay. Second, this method I have given is the industrial method. Please write down below. This is the industrial method of preparation of amines. This is the industrial method of preparation of amines. Okay. Then write. The mixture of amines obtained. The mixture of amines obtained is separated by fractional distillation.
Pardon, sir.
The mixture of amines obtained is separated by fractional distillation. Fractional distillation. Okay. So now we'll go for preparation of primary amine. Second is preparation of primary. Here we are only going to get primary. Can you see? Preparation of primary. Okay. So we are going to look for those substances where nitrogen is there. Okay. So we'll write here 1. Reduction of nitro compound. Nitro reduction of nitro compounds by catalytic hydrogenation. So what we'll do now, bracket will write H2 nickel or palladium. Written, comma, tin HCl, iron HCl, zinc HCl. All of them, they produce nascent hydrogen. Like that. All of them is only for your information. All of them produce nascent hydrogen means atomic hydrogen. NaSCENT, nascent hydrogen. And lithium, aluminium hydride, give corresponding nitro, sorry, give aliphatic or aromatic primary amines. Okay, so let me take here CH3, CH2, NO2. Okay, I'll do it now. Hydrogen gas. What I have to take here? Nickel or palladium. I have to heat it. Then you'll get here CH3, CH2, NH2. Okay, see how many hydrogen I require. I require 2 hydrogen for nitrogen, and for each oxygen I require 2 hydrogen because they will be expelled as water. So here I require 2, here I require 4 because we have 2 oxygen. Okay, so right now here 2 oxygen. So how many hydrogen I require? 4 plus 2, 6. That is I have to write here. So this is we have done by hydrogenation. Second, I am producing hydrogen by the reaction of these metals. Okay. So whichever metal is there in your lab, you can use it. So I'll write now here atomic hydrogen. Nascent hydrogens are unstable. So I have to write within square bracket. In your book, of course, they did not write it like this. Let us try to follow the convention. We should know chemistry. Suppose I have taken here tin HCl or iron HCl. Okay. This if right here, you get this. This practice is done by BSc student. Okay. So it is not difficult. It is a matter of only say around 10 minutes it takes in the lab to prepare a meal. You will get now here NH2 plus 2H2. I'll show you how the hydrogen is produced here. Let me take tin. So tin plus concentrated HCl. Okay, it gives you stannous chloride, and that's because you are immediately reacting it. So this hydrogen immediately will going to react. Same, if you do it iron, it will give you FeCl2 plus 2 hydrogen atom. If you do with zinc, it will give you ZnCl2 plus 2 hydrogen. In laboratory, generally we use zinc because zinc is cheaper. Tin is costlier. So I'll do the last one. Okay, last one. You will get here CH3CH2 NO. See, lithium aluminum hydride does not supply hydrogen molecule, does not supply hydrogen atom, but it supplies H minus ion hydride. They are the strongest reducing agent. Okay, so here I'm not going to write anything here. I'll simply write it here 1 lithium aluminum hydride followed by addition of water. So here you will get CH3, CH2, and H. Plus it will give you water. Okay? Do.
Yes, sir.
Written now?
Yes, sir.
These are
Yes,
all
sir.
aliphatic keys. Okay. Now we'll go for. Acha. Please here below that you write nitroethane. Nitroethane. There. Nitroethane. Huh? Nitroethane. Nitroethane. Please write. You should know the name of the starting material as well as the compound. Nitroethane, nitroethane, nitroethane. Make a habit, then you will find you will not forget the name. Une ethylamine, ethylamine, ethylamine. Okay. So suppose I have taken now this. So this is called nitrobenzene. So what you will get now here? See, this method can be used for preparation of aliphatic and aromatic aniline. Here also write nitrobenzene. This is aniline, please write. This is also nitrobenzene. And this one is aniline. Please, preparation is same. Because you have written no? corresponding aliphatic or aromatic primary amines.
Yes, sir.
Yes, sir.
Then next, right? Reduction of nitriles. Reduction of nitriles or cyanides. Reduction of nitriles or cyanides. This is second. Reduction of both aliphatic and aromatic nitrite or cyanide. Cyanide is a very old way of calling them. IUPAC we call them as nitrite. With catalytic hydrogenation. How will you do it? By taking hydrogen in presence of nickel or palladium. Okay. Then sodium in absolute ethanol. What you will do now? You will take sodium metal and you will add it to ethanol. It's a very strong reducing agent. Reni nickel. Reni nickel is an alloy of nickel and aluminum, dear. Nickel and aluminum. In sodium hydroxide or lithium aluminum hydride B with corresponding alkyl amine. See, very interesting. When I have taken nitroalkanes, I have got aliphatic amine. When I have taken nitroarenes, I have got aromatic amine. But in this case, both of them will give you aliphatic amine. I'll show you. Okay. So here I have taken here CH3, CH2. Look here. How many bonds we have? We have 3 bonds. Okay. So I write here now H2. Use little bit of your brain. It's very easy. Here, CH3, CH3. It is an addition reaction here, not a substitution reaction. See, it was sorry. See why did I say sorry? This is there, na? So this carbon is taken 2 hydrogen and this nitrogen is taken 2 hydrogen for each double bond. All right. So how many hydrogen I require? 2 plus 2, 4. So I'll write now here 2. So here I'll write here nickel or palladium. Generally we take nickel. Palladium is very costly. 10 gram of palladium may cost around 30 to 40,000 rupees. Okay, it's not possible to get this one. It's an addition reaction. Okay, now second, I can do it with, see, reaction of sodium in ethanol gives you atomic hydrogen. I'll show you how does it give. So I'll write now here sodium ethanol. So this. What is the name of this one? In common name is ethyl cyanide, and IPC name is propane nitrile. I'll prefer to write both. Ethyl cyanide. Till now we use common name because it's easy for us to say. Or propane 1, 2, 3, na? And nitrile N starts with a consonant, so E will be there. Propane nitrile. What do you get here? You get propanamine or propylamine. You get now here propan, because the moment it becomes more than 2, you have to put number. So propan 1 amine. So Rust, you will write the name, okay? So I'll show you where from the hydrogen comes. It's a very vigorous reaction. Sodium reacts violently with ethanol. You get this and this nascent hydrogen. So this is the hydrogen which reduces this. Achha, now this reaction is very important for your exam. This one. Why? The reason is this. The reduction of nitriles by sodium in ethanol is called Mendius, MENDIUS, Mendius reduction. Okay, finish. Then after I'll write on the top. This portion you have written, I think, na? Upper portion.
Yes, sir.
Yes, because I can verify. Ben knows I have developed that twin. Now third. So it is A, this is B, C, CH3, CH2, CN. Again 6, sorry, 4 hydrogen. I'm showing all these things only for your entrance exam. Because of that, the classes are becoming a little longer. Okay? And right now here Ni, this is the Reninical reactor. It will give you CH3, CH2, this will be CH2, and this will be Na. Okay. It may be a little tedious for you. You may abuse me also, but you should know. We should not miss anything, even though we are not meeting each other. This I will do with you. I have already told you, whenever you use lithium aluminum hydride, we will not write any hydrogen here. Okay? 2 H2, which will give you CH3, CH2, CH2.
Done, sir.
Written.
Yes, sir.
Yes, sir.
Okay, now see here. If I have taken see, if I have taken here, this is called phenyl cyanide, common name, and IUPAC name is benzonitrile. Phenyl cyanide or benzonitrile. See, very interesting thing. Here you get what? Here you get, see, this is not aromatic nitro compound because it is CH2 is there. See, this here it has taken 2 hydrogen and here yes, it has taken 2 hydrogen. So we call this to be benzylamine. Benzylamine is aliphatic there. Benzylamine is aliphatic. Okay? So please, for everything again you write it. So we practice for you. Right. A, B, C, D. Same way. And write the name of the compound also. Right.
Sultan.
You've done all 4.
Yes, sir.
Hello? So this is not the preparation of aromatic amines. This is the preparation of aliphatic amines. Done.
Sir, when we
Okay.
use lithium aluminum hydride, do we get water, sir?
Yeah, water will get. But I am not writing water, you know, because we are already adding water now. Because of that, I am not writing it.
Okay, sir.
Finished?
Yes, sir.
Okay,
Okay.
sir.
Then please write the next one. Right. Reduction of primary amines. Reduction of primary amines. Right. Reduction of primary amides by sodium in ethanol. See, this is not being given in your textbook. All right. So please don't write for your school exam. Or lithium aluminum hydride with corresponding. I'm little scared of your school. Corresponding primary amines. So this also will not give you aromatic amines. I'll write primary aliphatic amines. So I'll write now here CH3 CO NH2. What is this? This is called acetamide. And IUPAC name is ethanamide. Okay. So here I'll write like this. Okay, I'll make it shortcut. See, what you want here. I'll write the product. Then you will find out how much amount of hydrogen you require. CH3, CH2, NH2. See here. This oxygen is being removed. This oxygen will go out in the form of water. When this goes, valency of carbon from 4, it becomes 2. So you require 2 more hydrogen. So how many hydrogen you require? You require here 4 hydrogen. Okay, so you write here now sodium in ethanol. Okay. So here you can write here H2O. So it will give you ethyl amine or ethanamine. For lithium aluminum hydride, we will not write anything here. We'll write here 1 LiLH4 to water. Okay. So I'll write that here CH3, CH2, and write the name below. Same name again you write. Huh? You may feel it is a little boring, but one day you'll find all the names you'll be able to remember. Okay? Now I'm not going to write anything here. You have to do it. All okay? So this is only I'll write down the name. Huh? It's called benjamide. In your board exam, they will give you benjamide. But in entrance exam, they just to confuse you, they may not give you benjamide. They will not give you the structure, only the IUPAC name. Okay, so what is the IUPAC name of this one? We call it benzene carboxamide. Okay, reagent you will write, and you will write the product. Same thing you have to write. So this will be going to CH2, and you know the name of this one. It is benzyl amine. This is called benzyl amine. Please do the next one also. Okay, finished.
Yes, sir.
Then write a very, very important reaction is by Hoffman bromoamide reaction or Hoffman degradation. This is going to come next year in board exam. Hoffman bromoamide reaction or Hoffman degradation? When a primary amide is treated with cold solution of sodium hydroxide or potassium hydroxide and bromine form corresponding primary amine with one carbon atom less than original amide. So suppose I have taken here CH3CO NH2 and I have added here sodium hydroxide and bromine. You'll get here, see this will go, you'll get here CH3 NH2. Okay, plus you get here 2NaBr. Then you get here sodium carbonate. And let me see how many molecules of water. 3 molecules of water. 2 molecules of water. 2 H2O. See, why do you call degradation? Because this molecule is being broken down and this carbon goes out in the form of carbon dioxide, reacts with sodium hydroxide to give you sodium carbonate. So it has one carbon less. So what you get here now? You get here methyl amine. Okay. Now if you have taken benzamide, CO NH2. So benzamide will give you 4 NaOH plus Br2. See, this will go out. So what you get now here? You get here NH. You get an aromatic amine, aniline. Okay? Plus 2 NaBr. Na2 CO3 plus H2. So these reactions are very important. This. Okay, then for today, class is finished.